today what we're going to do is we're going to go over topic 11.1. It will be found on pages 286 to 289 in your book. Why don't you open your book right now and we will get started with the lesson. Alright, let's look at page 286 from the Pearson Realized book. Okay? This lesson is all about understanding percents. Now, we've already discussed percents a number of times, but now we're going to do the official book lesson. So, they give us a question. What is a percent? Well, in this case, we then have some information to help us out here. So, we're going to go over what they give us. A percent is a special kind of ratio. All right, in which the first term is compared to 100. That's important because we've oftentimes talked about percents being based on 100. The percent is the number of hundredths that represents the part of the whole, okay? So in other words, what we're talking about is we are talking about an amount based on 100. Okay, that amount could be any amount. Okay, it could be 5 out of 100. It could be 75 out of 100. Okay, so when we talk about our ratio, we're basing it on some term compared to 100. Okay? So everything would then need to be converted to 100. All right? Now, the book then gives us a situation. What percent of the people prefer bright white toothpaste? And then they give us our toothpaste diagram over here and a little box or bubble that tells us that 7 out of 10 people prefer bright white toothpaste. Okay, so what we're looking at is we're looking at 7 out of 10 people like the toothpaste. Okay, so 7 out of the 10 like the toothpaste. What we want to do then is we want to think of this based on 100. So you can see now where we want to go from 10 to 100, and of course we would multiply by 10, and then 7 times 10 would give us 70. So we would have 70 out of 100, okay? Or we would have 70%. So the book basically is trying to get us to understand that this situation represents 70% of the people like bright white toothpaste, okay? So we're going to take a look at how the book illustrates the process, okay? One of the things that the book will do is to use a grid model, okay? Now the grid model is based on 100 squares, okay? 100 squares set up in 10 columns and 10 rows, okay? So you have a 10 by 10 grid, which would equal 100 squares. And so if you wanted to model 7 tenths, what you would have to do then is you would have to say, okay, I want to shade in 7 groups of 10, okay? And so you would shade in 7 groups out of the 10 groups, okay? Which would be 70 total little squares. So you're going from 7 to 70 and from 10 to 100, which means that you would have 70% of it shaded in, okay? So that's a classic example there to use the grid system. Then they tell you another way to do it is to use number lines to model a percent. So you can model the percent using the grid system, or you can model using number lines. All right? So in this case, their initial number line is based on 7 out of 10. So they set up their number line, they went to 10, and what was important is you then break it up evenly into tenths, okay? And then what you'd want to do is say, okay, well, I'm going to take the same length number line, and at this time, though, I'm going to break it into hundredths. Now, you're going to see in your book, you've got a lot of little small lines in there, but basically, you'll see where the 1 is right above 10. You'll see the 2 is right above 20. You'll see the 3 is right above 30, okay? And so once you get done numbering all of those, you'll see that your 7/10 falls on 70 100ths. And so again, you can see where you have your fraction of 7/10, which is, which is easily converted through proportions to 10 times 10, and then 7 times 10, which equals 70, okay? And then, of course, if you have 70 out of 100, you have 70%, okay? Now, the one thing you can remember, though, is that you can actually take a fraction, such as 7/10, and treat it as a division situation, okay? So if we have 7 divided by 10, we're going to annex a 0 and a decimal point in there and ask ourselves, well, 7 can't go into 10, but 7 can go into 70. So 10 will go into 70 7 times. 10 times 7 is 70, and we terminate. Now notice how what we have here is 7/10. Well, if we make 7/10 into hundredths, the equivalent in hundredths, you'll see that you have 70 hundredths, which is the same as what we get on our number line model or our grid model. And then all we have to do is move our decimal point 2 places over and convert it into the percent symbol. Okay? So there's several ways you can actually model this amount as a percent. You can use the grid system, you can use number lines, or you can use division, which we've learned a couple of times in class. All right? Boy, that is one busy slide. So anyways, let's turn to page 287 and actually practice writing percents. Okay? So in 7 through 13, they want you to write the percent of each figure that is shaded. So why don't you pause the video and see if you can do 7, 8, and 9. All right, let's take a look at what we have. If you look at number 7, you can see that we have a 10 by 10 grid, okay? So we have 100 squares, and we can see that we have one full row shaded, which means that we have, out of there we have 10 little tiny squares, all right, which would be 10 plus the 1, 2, 3, 4, which would equal 14 out of 100. And again, we know that that would then be 14%. And our answer then would be 14%. All right, and again, if you wanted to, you could do division and actually divide 14 by 100. But in this case, you know that you have 14 out of 100, so that will be 14%. All right, let's take a look at number 8 and see how you did. Okay, so in this case, again, we have another 10 by 10 grid, which means we are working with 100. And when we look at the number of columns that are totally full, we have 1, 2, 3, 4, 5, 6, 7 total columns filled in, okay? And that would mean 70 squares plus 1, 2, 3, 4, 5, 6, 7 squares that are individually filled in, which means that we would have a total of 77 hundredths. And if we convert that, that means that we have 77%. There you go. Now, number 9 gets a little bit trickier when you look at it, okay? And you can see that in number 9, we will have a total of 1 out of 1, 2, 3, 4, 5 squares. So we have a ratio of 1 to 5. Now, there's a couple ways we can set this up. We could set it up and say, okay, well, we know that we want to get to a comparison of 100, so I can create equivalent ratios. 5 times 20 equals 100. Multiply 1 times 20, and that would give me 20, which is then going to be 20%. Okay? And that is what our answer is. But remember, you can also take 1/5, and that is a division expression, and divide 1 by 5. So you'd have to put in your decimal point, annex is 0. 5 will go into 10 2 times. 2 times 5 is 10. Subtract and you terminate. Now remember though that we need to make this based on hundredths, not just tenths. It has to be hundredths. So then we would see that we would then move our decimal point over 2 places, turn it into the percent symbol, and we have 20%. All right? And so that's how you answered number 9. Okay? Let's see how, why don't you pause the video if you haven't done so and try problems 10 through 13. All right, let's take a look at number 10. Okay? Number 10, they give us a number line, and the number line is broken up into tenths, and they've highlighted 6/10 of it. So for number 10, it would look like a ratio of 6/10 to begin with. And again, you can simply say, all right, I need to create an equivalent ratio with a 100 as its second term. So 10 times 10 is 100. 6 times 10 is 60. So we have 60 hundredths would be 60%. So our answer for number 10 is 60%. And again, if you did it using division and you treated it as a division expression, okay, you would put in your decimal point, annex a 0. 10 into 60 will go a total of 6 times, okay? 10 into 60. 6 times 10 is 60. It terminates and you end up with 0. Now remember, this has to be based on hundredths, okay? So you would then say I can have 60%, because you'll take your decimal point over, turn it in to a percent symbol, and you have 60%. So if you did it algorithmically through division, that's what it would look like. Number 11, when you look at number 11, okay, we have a number line that is broken into 20 sections. So our second term is 20. Our first term is 14 because we've highlighted 14 out of the 20. And so again, you could simply say, okay, 100 is a multiple of 20. 5 times 20 is 100. So I multiply 14 times 5. If I take 14, I multiply by 5. I see that I get 20, carry the 2, and I end up with 70 over 100. And so the answer to number 11 is 70%. But remember that this would have to be written as a percent. And again, we could do it algorithmically by asking ourselves, okay, if I divide 14 by 20. I put my decimal point in, annex a 0, bring my decimal point up. 20 will go into, I'm sorry, I mixed that up there. Yeah, 20 cannot go into 14, but it can go into 140. It will go in 7 times. 7 times 20 is 140. Subtract and you have 0. And so remember that we have to base them on hundredths. So we add another 0 to get an equivalent. So in other words, this is equivalent to this, which then can be turned into this, because you just move your decimal point over 2 places and make the percent sign. Okay? All right, let's take a look at number 12. Okay? Number 12. Number 12, they have a number line that is going all the way up to 100, and they've shaded in 82 out of 100, so we have 82 over 100, and we don't really have to do any math here because we know then that it'll be 82%, because you have 82 out of 100. Okay? Number 13, they switch things up on you a little bit. Okay? And so for number 13, if you look at it, we have a number line that is broken up into 200ths. So our second term is 200. And then they tell us that we have 100 of 200. Now, most of you at this point are realizing that, you could use division to divide by 2 to take it down to a ratio based on 100, and divide that by 2, and you would get 50, which means you'd have 50 out of 100, which is 50%. But some of you just said to yourself, you know what? The whole distance here is 1/2. So from here to here is half the distance. 1/2 is equal to 0 and 5/10, which would be equal to 50%. Okay? So there's a number of different ways that you can look at the many different situations for making percents. You can use models, you can divide, you can make equivalent ratios. All right, if you have any further questions, you can watch the Pearson Realize video or see your teacher or parents for help.